Whenever we begin teaching a new subject, we always begin by introducing that subject and what that subject aims to do or to solve. When it comes to calculus, we are aiming to solve two main problems, the area problem and the problem of the tangent line. And in our aim to solve these two problems, new concepts and new operators will be introduced. But before we attempt to solve these two problems, we have to make sure that we understood them completely and correctly. For the area problem, we all know how to find the area of the basic shapes, like the area of a square, a triangle, a rectangle, and circles. We all know how to find the area of these basic shapes, but as a reminder, the area of a square is a side square. The area of a rectangle is a half multiplied by the base times the height, and the area of a rectangle is width times height. The area of a circle is pi r square. And if we encounter a new shape, like a new polygon, for example this shape, we can find the area of these new shapes by dividing the shape into the basic shapes we know the area of. For example, for this shape, we have divided this shape into 4 triangles. Now the area of the whole shape is going to be equal to the area of each rectangle separately. Let's name them A1, A2, A3, and A4. So the whole area becomes A1 plus A2 plus A3 plus A4. And up until now, we have used this technique to find the area of the shapes we didn't have a formula for. But what if we encounter a curved shape? For example, this shape here. How to find the area of this shape? And this here is the problem of the area. In calculus, we're going to attempt to solve this problem. Now for the problem of the tangent line, it goes like this. We know that every line has a slope, and we denote the slope of a line by this symbol, and we can find the slope of different lines by using the rise over run formula, y2 minus y1 over x2 minus x1. This gives us the slope of a line. So where is the problem here? Well, the problem is for a tangent line, and a tangent line by definition is a line in which it touches a curve in one point and one point only. Say for the point P, a tangent line is such a line. It will only touch this curve on the point P. So we only have one point lying on the line. So how are we supposed to find its slope using the rise over run formula? Because the rise over run formula requires 2 points. So this is the problem with the tangent line. We will begin our journey in calculus learning about functions, and anything we do after learning about functions is going to be to come up with ways with working with functions. After learning about functions, we will proceed to learn about limits, how to take the limit of a function. And after that, we will encounter the derivative. And using the derivative, we will solve the second problem introduced in this video, the problem of the tangent line. And after the derivative, we will learn about antiderivatives or the integral. And using the integral, we will solve the first problem introduced in this video, the problem of the area. So the derivative will enable us to get the slope of the tangent line, and the integral will enable us to find the area under a curve. And all of these different concepts will revolve around functions. We take the limit of a function and we differentiate a function and we integrate a function. The symbol for the limit is the limit of x approaches a number, and for the derivative we take the derivative of a function. For the limit we also take the limit of a function, and for the integral we integrate a function from a point to a different point.